Hello students, welcome. Hello students, this is Kaynat from Alampool and today we are on the lecture 7. And we will know about graphs today, graphical representation of motion. Yeah, this is very interesting. So, graphical representation of motion. सबसे पहले we will study about the distance time graph, then velocity time graph, and then we will study about acceleration time graph also. Okay, so first velocity time graph, sorry, distance time graph. First distance time. Let's start with the very initial. Suppose this is a graph. This is a graph. Okay, here it is distance. Here it is time. Time is usually taken in the along the x-axis, and the other quantity is taken in the y-axis. Okay, so obviously this is the origin. So let us first consider the very initial thing, that is let the body be in rest. So how our graph will look like if our body is at rest. Okay. So very first here, this is your first, which is about rest. Okay. So for rest, it will be like this. It will be like this. How it will be like this? Here you are seeing it is clearly visible that distance is remaining the same, right? Distance is the same, but the time is increasing. Time is increasing, right? So if time is increasing and distance is the same, then obviously the body is at rest, right? Because here the time is increasing but the body is not moving because its distance is not getting changed. It is at, suppose it is at some d distance, and it is again a distance at time t even. Okay, so in time t it hasn't moved to anywhere. So that is why we'll say that this graph will represent the motion, will represent the body at rest. Okay, now the second. Okay, so second will, let us take again distance this and then time, and the x-axis origin as o. Okay, now the second motion, what it would be like. So let us take the graph like this. Now what this graph is representing, this graph is representing the motion is uniform, because here as the time is increasing, as I have already told you, that uniform motion means what? The distance get increased along with the time, equal distances in equal interval of time. So that is why here you will see that the increase in distance is according with the increase in time. And that is why the straight line graph of a distance time, the straight line path of a distance time graph is always represent a uniform motion. That is why second is representing what? Uniform motion. Now the third one obviously it would be non-uniform. So let us see how our non-uniform motion would look like in the graph. Okay, so again let us take all these again, d and t. Now the non-uniform means unequal distances and equal interval of time. So it would be like this, it may be like this, it may be like this. Okay, it may be like this, it may be like this. Okay, so these all curves are representing what? Non-uniform motion. Okay, because here it is not certain that where the when is the distance is increasing and when is the distance decreasing along with the time. That is why we will say that this all types of graph will represent non-uniform motion. Okay, so these all types of graph will represent non-uniform motion, any of them. But as a whole it will see, if you will delete this and this, then as a whole it will look like it is non-uniform. But for this, suppose o to a, it will be uniform, right? Because it is a straight line. If we talk about just o to a, it would be what? Uniform. But if we talk about the whole journey, then it will be non-uniform. Okay, so mind it. So it can also be asked like this tell that OA, how is it? what kind of motion is representing by OA. So O is representing uniform motion, but the whole journey is representing non-uniform motion. And suppose AB is also representing uniform motion in the backward direction. Okay, in the backward direction, because here also time is increasing. Your one of the graph for uniform motion can also be like this. I forgot to tell you. One of the graph for uniform motion can also be like this. Suppose someone is going, starting from, someone has gone somewhere and then he's returning back. He's returning back from somewhere. So it is also a straight line graph which is representing uniform motion. Okay. But if it would be like this, then the whole journey would represent non-uniform motion. Clear? Okay. Now the second comes velocity time graph. The second comes velocity time graph, VT graph. Okay. Now the VT graph. So here, let us take this as V, and then time is will be obviously in the x-axis. Okay. So V. Now see the very first uniform motion. Okay. The very let us take very first as rest. Let it be rest. Okay. It is not very well known, but I am telling you. So let us take the body being we are at rest. Now अब रेस्ट में कैसे बनेगा ग्राफ? तो रेस्ट में जो ग्राफ बनेगा वो सी वेरी वेरी केयरफुली, रेस्ट वुड बी लाइक दिस. Rest would be like this. How rest would be like this? Because velocity is zero at this point, right? Velocity is zero at this point. Here velocity is not increasing, but the time axis, but the time is increasing. It means what? If velocity is not increasing, it is at rest. Means the body is having 0 meter per second velocity, zero velocity, and time is increasing. It means what? The body is at rest, obviously. But the graph cannot be like this. Graph cannot be like this. Why it cannot be like this? Because here it is representing that velocity is increasing, but time is not increasing. How can it be possible? This cannot be possible, right? So this is wrong graph. If a graph is given to you like this, what kind of motion it is it representing, then you'll say this graph is wrong. Why? Because this representation of motion is wrong. Why? Because here velocity is increasing, but time is not increasing. That is why this would be wrong. Also this would be wrong. Means starting from this A point and ending up at point B. Time cannot go backward. Time cannot go backward. Okay, this is also wrong representation. Fine. If it is going like this, then it's okay. But if it is shown like this, then it's wrong, right? Okay. Okay. Now the rest is done. Now the second one, uniform motion. Okay. So this is V, this is T. Okay. Now we have to represent uniform motion. Uniform motion, the time should increase, but the velocity should not increase in the uniform motion. This will be the uniform motion. How? Because here the velocity is constant, but the time is increasing. It means that the body is moving with a uniform velocity, the same velocity, constant velocity. So the motion would be uniform. So the motion would be uniform. Okay, got it? So uniform motion ये हो गया. Now the third one, non-uniform. Non-uniform. Now how would this motion would look like? VT. देखो जैसा डिस्टेंस टाइम ग्राफ में यूनिफॉर्म मोशन था ना, वैसा ही इट विल लुक लाइक इन द नॉन यूनिफॉर्म मोशन फॉर VT ग्राफ. Okay. So this will be origin. This would be non-uniform. How I am saying that this is non-uniform? How this is non-uniform? Because here velocity is increasing. Velocity is increasing. This is accelerated motion. Do you see that? This is the accelerated motion. Here velocity is increasing with the time. So that is why this is accelerated motion. And if we talk about like this, so this is also non-uniform motion. Why? Because this is also accelerated motion, but the acceleration is uniform here. This is also called uniform acceleration, right? Uniform acceleration because the velocity is increasing equally with the time, right? Velocity is increasing equally with the time. That is why the uniform would the Uniform would be acceleration, but non-uniform would be velocity. Non-uniform would be motion, because as soon as acceleration comes into play, the uniformity of the motion gets destroyed, right? So यहाँ पर acceleration आ गया तो uniformity motion की खत्म हो गई, but velocity here, velocity is increasing equally with the time. That is why I'm saying कि this is uniform acceleration but not uniform motion, because velocity is getting changed with the time. Okay, so that is why we will say, so it, इसको फिर से सुन लेना जो हम बोले हैं, because it should get clear to you. Okay, so here velocity time graph in this, it is representing non-uniform motion but uniform acceleration. Okay, now the fourth one also would represent non-uniform motion. See here, non-uniform motion but uniform, I am writing here uniform acceleration, but in this non-uniform motion also non-uniform acceleration. Okay, non-uniform acceleration. Here see, it is representing uniform deceleration. Okay, because it is in negative, because velocity is decreasing here, so that is why I'm saying deceleration. Okay, or you can say retardation, or you can say negative acceleration, but the acceleration is uniform. Okay, negative acceleration is uniform. Now non-uniform motion also non-uniform acceleration. So now how it would be look like? Vt. Okay, Vt. Now this is origin. Now if it would be like this, if it would be like this, or it would be like this, okay, or it would be like this, these all are representing non-uniform motion and non-uniform acceleration. Velocity is sometimes increasing, sometimes decreasing, sometimes increasing. Here velocity is not increasing equally with the time, right? So that is why here, so in this and this, sometimes it's getting decelerated, sometimes it's getting accelerated, but in this the body is whole accelerating, but it is not accelerating uniformly. Okay, that is why I'm saying this motion is non-uniform as well as non-uniform acceleration. Okay, is it clear? Fine, तो ये हो गया. Now the acceleration का थोड़ा सा देख लेते हैं. Acceleration का दो ग्राफ होगा. Okay, so the third one is AT graph. That would not be in your course, but still I'm telling you. So AT graph, that is raw. Let's take A here and T here. Okay, so AT graph, if it would be like this, can you see that? Is it clear? If it would be like this, तो पहला ग्राफ क्या रिप्रेजेंट कर रहा है? What is it representing? What is it representing? Tell me, what is it representing here? Acceleration is zero. I don't know about velocity, but acceleration is zero here. Time t. Maybe it may be कि velocity can be zero or velocity can be something, but acceleration is zero. So we can say that body can be at rest. We are not sure if body is at rest or uniform motion. We cannot say anything about this. Okay, we can, but time is increasing, but if velocity is something or not, we are not knowing about velocity here, but acceleration is zero. That is why we would say it may be rest or uniform velocity. Okay, if there would be some velocity, then it would be uniform velocity, uniform motion. Okay, because a is zero here. Now the second, a t. So let's take like this. Now what is it representing? AT. Here A is constant throughout the journey, but the time is increasing. A is constant, and A is something, A is some number, because there is some gap between 0 to A. That is why A is something, but it is constant throughout the journey. So, but there is acceleration. That is why the uniform acceleration. That would be representing uniform acceleration, not uniform motion. Okay, uniform motion nahi hoga. Why? Because acceleration is there. The uniform acceleration would be there, but not uniform motion. Okay, तो ये clear है. अब now the third one, तो चलो third को ऐसे बना देते हैं. Okay, now here acceleration is getting increased. Acceleration is getting increased with the time. It means that it is changing with the time, and we will say even if it is like this, acceleration is getting changed with the time, right? Acceleration is getting slowly reduced with the time. So in this case, what we would say, there is non-uniform acceleration, right? And in this case, non-uniform deceleration. Okay, so that is why we are here, non-uniform acceleration or deceleration. Okay, so this is representing non-uniform acceleration because it acceleration is getting changed with the time. So it can also be like this, it can also be like this. Okay, these all are representing non-uniform acceleration. Fine. So this is it for today. I hope that you must have had understood everything to what I wanted you to make understand. So tata bye bye for today, and keep on liking the liking the videos. Okay, bye bye.